Okay, so good morning, students. Today we continue our discussion on the previous videos also. So we will be discussing about boiler performance. Okay. So today also we'll be taking another one, another different numerical about boiler performance and see that okay how we can solve it. Now, for this question, okay, so now the boiler performance is there. So the observations were made in the plant for a 1 hour test. Okay, the steam pressure is there is 20 bar. So compared to all the other problems that the previous problem that we saw, okay, so here the steam pressure it is higher. Okay, the steam pressure is high. Then the steam temperature is there that is given as 260 degrees Celsius. So we need to look at the steam tables to say that okay if the steam is in what is the condition of the steam is there. Then the amount of steam which is generated, okay, so that is 37,500 kilogram, and this I want to remind, we have to remind, okay, so we have to look that yeah, this is for a 1 hour test, okay, so in 1 hour that amount of steam generated is 37,500 kilograms, so that is a huge amount of steam. Then the temperature of the water that is entering the economizer, which is the entering, it is entering the economizer at 15 degrees and it is leaving the economizer at 90 degrees. Then for generating 37,500 kilogram of steam which is there, the amount of fuel which is used is 4,400 kilogram and the calorific value of fuel it is 33,000 kilojoule per kilogram. Now I am based on this given data which is there, okay, so I am supposed to find out what is my equivalent evaporation per kg of fuel. Then I am supposed to find out the thermal efficiency of the plant. Then I am also have to find out how much is the percentage of heat energy, okay, in the fuel which is utilized by the economizer to increase the temperature. So here, okay, how much is the heat that is used by the economizer to increase it from 15 degrees to 90 degrees. So firstly I will be finding out what is the enthalpy rise, and then we'll be correlating that with the my mass of fuel used. Okay, so accordingly we'll be able to find out how much is the percentage of heat which is added. Now we'll start the problem. Okay, so firstly I will be firstly what I'll be noting down is my mass of steam which is there. Okay, so my mass of steam denoted by ms equal to 37,500 kilogram. Now this is for 1 hour test. Okay, so for per hour this is per hour. Okay, so all the values which are there, okay, so will be in per hour. Secondly, the steam pressure which is there, my steam pressure it is given as 20 bar, so ps equal to 20 bar. Then the steam temperature which is given, so this temperature is here, the temperature of the steam at outlet which is there. Okay, now temperature of the steam, okay, so that is 260 degrees Celsius. So after, okay, so we'll be checking our steam tables and see if this temperature is there. Okay, so what temperature it is. Now we have, since we have an economizer here, okay, so we'll be slightly changing the notation. Okay, so it will be TEI, so denoting the temperature of water, okay, at the economizer inlet. Okay, so that is 15 degrees Celsius. Then the temperature of water at the economizer outlet which is that is given as 90 degrees Celsius. Then my mass of fuel which is there, my mass of fuel it is 4,400 kilograms, and the calorific value of the fuel that is 33,000 kilojoule per kilogram. So now we have listed out all the given data which is there. Now from the steam tables which is there, okay, at ps equal to 20 bar. Okay, so what I'll be looking at is that what is my saturation temperature. Okay, based on the saturation temperature, if my temperature of the steam is that is less than the saturation temperature, okay, so then we will have to find out the enthalpy of the steam which is there. Okay, so then if it is more than my this temperature is more than the saturation temperature, then obviously what happens, my steam which is there, okay, so the steam which is there that is in superheated condition. So then I can, what for my values which is there, I can refer to my superheated steam tables. Okay, so at the PS equal to 20 bar which is there, okay, so I am able to observe that my saturation temperature which is there, okay, so my saturation temperature is 212.4 degrees Celsius. Okay, so implies what I can say, my temperature of the steam which is there, that is greater than my saturation temperature. So implies superheated, the condition of the steam which is there, that is superheated steam is generated. So okay, so I have my superheated steam which is generated. So now which is the, so now that I have observed that I have my super steam conditioner is superheated. So then okay, so what I can do here, if it was in one of the previous problems which were there, okay, so there what we had, what there was the equation that we had used. We have used an equation like this. It's superheated, enthalpy of superheated steam is equal to Hg, enthalpy of saturated steam, okay, plus Cp of steam into T sup minus T sat. So in a previous question, previous question, we had used this expression, okay. But here, okay, so to, if here also I can use this expression, provided I know the value of the specific heat, okay, specific heat, that specific enthalpy of steam, right? So I know the specific heat capacity of steam. I should be knowing that. So if I know the specific heat capacity of steam, then I can very well use this expression. But since here I am not given this term, okay, so what I can do is that, okay, so in my steam tables I have the section called as the superheated steam tables, right? I know the superheated steam. So in the superheated steam, okay, so from steam tables, okay, so Ts equal to Tsat, then from the superheated steams enthalpy tables which are there, okay, so what I can take is that my enthalpy of steam which is there, okay, so my enthalpy of steam which is there, so if you are actually observing your superheated steams enthalpy table, so there actually it is in bars of 50, okay, so I have the enthalpies for 150 degrees Celsius, I have the enthalpy for 200 degrees Celsius, I have the enthalpy for 250 degrees Celsius, and so on. Okay, so I do not have like, but here my temperature of the steam which is there, that is given as 260 degrees Celsius. So then what I'll have to do is that, so here I'll have to take the values for the enthalpy of steam at 250 and 300 degrees Celsius, and then I'll have to interpolate them and get the value of the steam at the have to get the enthalpy of steam at 260 degrees Celsius. Okay. So for that, firstly, what I have to do, okay. So from enthalpy steam, superheated steams enthalpy tables, okay, at 20 bar, comma, this is it. So firstly, my enthalpy of superheated steam at 250 degrees Celsius, okay, so that is, I am obtaining it as 2902.4 kilojoule per kilogram. Then the enthalpy of superheated steam at 300 degrees Celsius, that I am obtaining as 3025.0 kilojoule per kilogram. So by interpolating both of these, okay, so what from by interpolating both of them, okay, so I can get, I am able to obtain that my enthalpy of superheated steam at 260 degrees Celsius, okay, as 2926.92 kilojoule per kilogram. So this is the value that I'll be using for our further calculations. Okay. Now, before actually we are proceeding, so firstly we'll have to find the enthalpy of the feed water at my economizer inlet. So which I'll be denoting which we are denoting at HF1. Okay, so that is equal to the same condition of the it is water. Okay, so CPW into TEI minus 0. Okay, so CPW 4.187 into the temperature of the water at the economizer inlet, which is that is given as 15 degrees Celsius. Okay, so 15 minus 0, that I'm obtaining it as 62.805 kilojoule per kilogram. So this is my enthalpy of the steam, okay, enthalpy of feed water at the economizer inlet. Next, which is there, okay, so enthalpy gained by the feed water in the economizer. We are denoting it by HE. So HE equal to CPW into whatever is my temperature difference, temperature rise in the economizer. So that is TEO minus TEI. Okay, so that will be 4.187 into 90 minus 50. Then I am obtaining it as 314.025 kilojoule per kilogram. So at the entrance of the steam, which at the entrance to the boiler which is there, my steam, it is already carrying the enthalpy of HF1. Okay, at inlet to boiler, okay, the enthalpy of steam which is there, that is already HE plus HF1. Then beyond that which is there, so further that whatever the enthalpy that is being added, okay, so this enthalpy that we found out 2926.92 kilojoule per kilogram, that is actually happening in my boil, that is happening inside my boiler. Okay, so now the enthalpy of the steam at boiler outlet which is there, okay, the enthalpy of the steam at boiler outlet, okay, so denoting by H1 equal to 2926.92 kilojoule per kilogram. Now what I can do is that now I can find out my evaporation rate. Okay. Because the I will be requiring the evaporation rate to find out both equivalent equivalent evaporation, for thermal efficiency, for the percentage energy in the economizer. Okay, so for all of them I'll be requiring the evaporation rate. Is evaporation rate denoted by Ma equal to mass of steam upon mass of fuel, which is there. So my mass of steam, it was 37,500 kilogram per hour, divided by the mass of fuel which is consumed, it is 4,400 kilogram. For 37,500 kilogram, 4,400 kilogram. Okay. So my mass of steam, which is my mass of evaporation rate, which is there, I am obtaining it as 8.523 K. So kg of steam per kg of fuel. Because here I am not given what is my what fuel it is. Okay, so it is just given as fuel used. So I am just writing it the same thing. Next, what I can do is that next I can proceed to my evaporation. Next I can proceed to my equivalent evaporation. Okay, so firstly I have my equivalent evaporation denoted by Me equal to Ma into H1 minus HF1 minus He upon 2257, because equivalent evaporation which is by which that we are considering just inside my boiler chamber. So I have equivalent evaporation here. Okay, so I have 8.523. Ma it is 8.523 multiplied by H1 2926.92 minus the enthalpy added in my economizer 314.025 minus 62.805, and this whole divided by 2257. So my equivalent evaporation is there. Okay, so I'll be obtaining it as and we are obtaining it as 9.63, obtaining it as 9.63, okay, and kg of steam per kg of fuel. So that is my equivalent evaporation. Secondly, I have to find out my thermal efficiency of the plant, denoted by efficiency of the. Now here which is there, okay, so since in my question I have been asked to find out the thermal efficiency of the plant, here what I have to do is that I have to consider my boiler. Okay. So here I have to consider my overall efficiency. Okay, so here I will be considering my overall efficiency, which is given by MA into H1 minus HF1 divided by the calorific value. So implies I have eta overall equal to MA is 8.523 multiplied by H1 2926.92 minus HF1, which is the enthalpy of feed water at the economizer inlet, that is 62.805, we already found out, divided by the calorific value of fuel, it is given as 33,000 kilojoule per kilogram, and then I am multiplying it by 100 to convert it into percentage. So implies I can get, what I can get is my overall efficiency which is there. Okay. So my overall efficiency I am getting it as 73.969 percentage. Now in this question, okay. So considering that I have the boiler and the economizer, so 73.9 percentage, so equivalent to 74 percentage. Okay, so I round it off to 74 percentage. So that is fine. That's actually a good efficiency for a boiler, considering that you are generating the amount of steam that you are generating. Okay, so that is 37,500 kilogram per hour. So that is actually a huge amount of steam. Now there is one more part remaining. Okay, so I have to find out the percentage of heat which is utilized. Okay, so find out the percentage of heat energy utilized in the economizer. So for that, what we'll be doing is that, okay, so we'll be taking the evaporation rate which is there. Okay, so then the evaporation rate multiplied by what is my enthalpy that is added in my economizer, and I'll be dividing it with the calorific value. Okay, so because I have to find out how much is the percentage of heat energy which is used by the economizer to the of the percentage heat energy of the total energy that is available. Okay, so the total energy available, that is 9. For that, okay, so I'll have to take my calorific value here, so that will be 8.523 into my He is 314.025 divided by calorific value is 33,000, and then since I'm asked a percentage, okay, so I have to multiply, I'm also multiplying it by 100. So this value, students, I am getting it as 8.11 percentage. So just because of using the economizer which is there, okay, so my if at all, okay, so what will be my efficiency here if my economizer was not used? Okay, so if my economizer was not used, then my efficiency of the boiler would have been, in this question which is there, my if the economizer was not used, my efficiency of the boiler would have been 74 minus 8.11 percentage. That comes out to be as 65.89 percentage. So that would have been the boiler efficiency of just the boiler. Considering that, okay, so with the without the economizer also, okay, so that will be under an assumption that without the boiler also, my feed water which when it was entering the boiler, it was at a temperature of 90 degrees Celsius. So if that temperature it is instead of 90, if that is becoming 15, okay, so then what happens? Okay, so my temperature of the feed water at the boiler inlet, it will be 15 degrees Celsius. Okay, that will not be 90 degrees Celsius. So more amount of energy that will be required to increase the temperature from 15 degrees to 260 degrees compared to 15 to 260, and then I have 90 to 260. So obviously 15 to 260 degrees Celsius which is there, okay, that will be requiring me more energy. Okay, so that is why the boiler efficiency which is that difference is coming in the boiler efficiency because of adding the economizer. Okay, so with this will conclude this problem. Okay.